Types of databases, there are three. One is known as a relational database, or we call it relational DBMS. The next type is known as a hierarchical and network DBMS, and the third one known as object-oriented databases. So there are a couple of slides related to each of these database. Let's look at the first one, relational DBMS. It represents data as two-dimensional tables called relation. So there are a lot of new terms that you need to catch up. So in terms of relational database or relational DBMS, in this database, the data is represented as 2D, two-dimensional, in the form of tables, and that table is known as a relation. That's why they call it relational DBMS. Relates data across tables based on common data element. So the tables you can always refer as a file, different file. For example, remember we have customer file, supplier file, patient file, invoice file, and so on. Some of these files or tables need to be linked so that the DBMS can pull out all this data automatically. So what will happen is there will be a linkage or links between these tables using common data element. For example, using the key field. Remember, I did mention about the primary field, secondary field, and foreign key. So using these fields, key field, primary and secondary and foreign field, this relation or these tables will be linked, so that when you create a queries, required information will be generated automatically. And examples of relational databases are such as DB2 belong to IBM, Oracle belong to Oracle, MS SQL belong to Microsoft, and so on. An example of relational data model, or they call it RDBMS. RDBMS, short form is RDBMS. You have all the relation or the file. The file is the term that we use in a traditional file, whereas relation is the term that we use in databases, which also can be referred to a table. So this table will have many columns, or in DBMS we call fields and attributes, such as part number, part description, unit price, and so on. And there will be thousands of records in each table, and that need to be linked. For example, the part number, and you see the end, there's a supplier number. So this supplier number and this supplier number can be linked. So that's how this table or this relation will be linked to this relation in DBMS. So they are all connected. They are all connected. Three basic operations in RDBMS or in relational databases are such as one of the basic operation is select. Select. Create subset of rows that meet specific criteria. So these are the methods or languages. Remember, we have DML languages, data manipulation languages, which can be used to create DML languages in order to pull the data from the databases, in order to manage the data from the databases. So queries or languages such as select, or operations such as select, join, and project can be used for certain purpose. So select will be used for create subset of rows that meet specific criteria, whereas join will be used to combine tables. Remember, I showed you the supplier data and the supplier data. So join is the command or basic operation will be used to combine the tables to provide users with information. Project is to enable users to create new tables containing only relevant information. So there are many more, hundreds or thousands of basic operation that can be done in databases, but definitely we are not going to share all, just to give you some ideas how the DML languages, data manipulation languages, is all about. So the three basic operation of RDBMS, as I just explained to you, are here in this slide, where you can see the part number, supplier number. So these two tables will be used to pull the data that you need. For example, you have supplier number and supplier number on both the relation part and supplier. So these two can be linked and pull the data you need, such as part number, supplier name, and supplier address. So this is a new file, new project selected columns from two different tables. So this is how DBMS can, on the real-time basis, pull the data that you need and display in the form of report or online information or real-time information based on demand. That is how the DBMS works. That is the beauty of the DBMS. Next, let's move on into hierarchical and network DBMS. It organizes data in a tree-like structure. It organizes data in a tree-like structure. So that's the reason why it is known as a hierarchical. Supports one-to-many parent-child relationship. Supports one-to-many parent-child relationship. One-to-many, I will explain to you shortly what it means. And prevalent in large legacy systems. So this hierarchical and network DBMS is quite a old database network, database DBMS compared to relational or compared to object oriented. So the newer software, the newer databases have moved away from this hierarchical and network DBMS structure, just for your information. But this is another type of database available. As you can see the example, the organization of the data is in the hierarchical format. For example, we have the employee file as a root, and then the employee file as first child, for example, compensation file, job assignment file, benefit files, and then further down in the next level is where you have performance rating, salary history, more details files as a working file sometimes. So that is what we call second child. So all these files are linked, connected, but in a hierarchical format. So for example, if you are looking for employee in terms of compensation, then you got to go down into the details such as performance rating and salary history. So that's how the files are connected, top down and bottom up. So this structure is what is being used in a hierarchical database, and the same way it goes how your data is organized or is saved or is stored, and the same method, the same ways will be used to retrieve the data, top down, bottom up. That's how it works. And this network DBMS slightly different from the hierarchical data, the logical data which are saved into the database. It has many-to-many relationship, meaning, for example, if you look into the files here, the employee relation here may be connected to another file. For example, maybe we can say employee and benefit files. Many employees, many benefit. One employee, many benefits. Many employees, for example, we can have another entity here which is also many, for example. So we can have many-to-many relationship most of the time, because we have many employees in one company and they have many compensation, many job assignment, many benefit. So normally network or hierarchical database will have many to many relationship among the entities or relation. So this is how it looks like. Another example, we have course 1, course 2, course 3. Course 1 itself, there is a one student, and student number 1 and student number 3 are taking course 1. Course 2 is being taken by student number 2 and student number 3 and 4 and so on. So what you see here is uh, many courses having linkages or link with many students, and that is what we call many to many relationship. And this is how the network data model, and this is how your data is being organized in the what we call database, network database. The disadvantages of hierarchical and network DBMS, as I mentioned earlier, this is quite a old structure, is outdated. In fact, not many companies or organizations are using this anymore. Less flexible compared to RDBMS, lacks support for ad hoc and English language like queries. All parts for accessing data must be specified in advance. So for this reason, the businesses have moved away from this type of databases, into newer databases such as RDBMS or even object oriented. Okay, with that understanding, let's look into the latest or the newer of databases, which is the object-oriented databases. Object-oriented DBMS, or in short form, we're going to call it OOD, stores data and procedures as object that can be retrieved and shared automatically, and normally it is on real-time basis. And this is a newer types of database, and in this database or in this DBMS structure, data and procedures are against object. Remember, I did mention object means you can always compare as an entity, or can compare as a file in our traditional file. For example, customer is an object, invoice is an object, supplier is an object, doctors is an object, student is an object. So each one of these entity or relation is known as an object in this OOD MBS. Yeah. Also can be used to handle graphic or multimedia application. So as the data is getting complicated or sophisticated, as we know today, our data is in audio, video, and more data are being converted into audio, like what I mentioned to you guys last week. Especially the videos that being uploaded into YouTube in a minute runs into hundreds of millions. So what it tells us? It tells us that the amount of data, the amount of videos that being uploaded into the data storage or into YouTube or any other service providers runs into hundreds of millions of sizes. Yeah. So more and more data are being available or being transformed into audio and video instead of text, like those days. So with that, we need such a sophisticated, complicated object-oriented databases to handle this data. Slower than RDBMS for processing large transaction, especially video types of data. Definitely it takes a longer time to process compared to non-video or audio or text. Yeah. Because it's very heavy, it runs into gigabytes, most of the time. And there is also another hybrid type of database which we call object relational DBMS, provides capabilities of both object oriented and relational. So it's a kind of hybrid database which is also available based on the business needs or business demand. All right, in the next slide, what we're going to do is we're going to discuss about how to design databases. Remember, one of the component in database is logical and design of the database itself. So when come to designing the databases, there are two steps involved. One, what we call conceptual design. Basically, this is to come out with the idea conceptually, or we call it abstract model of database from a business perspective. So based on the nature of the business, maybe it is a logistic related business, or retailers, or medical, or transport. It depends on the nature of the business. The database need to be conceptualized, conceptualized first, in terms of design. So there is no so-called standard design, or what we call template that can be used for all businesses or all cases. So we need to conceptualize that first before we can come out with the design, and then this design later will be implemented. This conceptual design will be implemented into a real databases, which we call physical design. So detailed description of business information, which we're going to call it as a physical design. That is when it is implemented from a logical into a physical. That is the whole idea. So when all the relations or tables have been created, and all these tables are uploaded with data, and the data are available for processing, we call that a live database, physical database, which is available to run your business. So these are the two main areas in terms of designing the databases, in terms of creating the databases. Remember, I did highlight earlier, all this job will be done by a person known as a DBA, database administrator. And normally this DBA is a very key person, very critical person in any organization. He will be quite highly paid, highly demanded, a very specialized person who has been trained in that platform or in that particular databases, and he has to be very familiar, and he has to be responsible and accountable for the data. Reason, he owns all the data. He is the owner of the data. No doubts the data is actually belong to the organization, but as far as IT is concerned, he has access to all the data. So basically he is responsible in securing, managing and maintaining the data. Reason, no other person in the company will have overall access to the data compared to this guy, DBA. So when come to designing the databases by this person or by this DBA, he needs to have very good technical knowledge, such as where you will be creating what we call entity relationship diagram. In short form, we call ERD. ERD, which is a methodology for documenting databases, which will show us or illustrate the relationship between the database entities. Remember, I told you, for example, we have customer, how the customer is connected to the product or services, and how the product and services are being supported by the suppliers, and how these products will be delivered, for example, by which transport company, and so on. So there are a lot of linkages or relationship between all these entities. So the method to show the direct and indirect relationship among all these entities is through this ERD diagram. And who is responsible for coming out with this ERD diagram is the person known as the database administrator. Sometimes he will be assisted by system analyst, SA, or by any other IT guy who has some skill or knowledge related to databases. Otherwise, the database administrator has to be responsible in generating the ERD diagram. The other tasks that need to be carried out during the designing of the databases by the DBA is also known as normalization. Maybe some of you are familiar with this term. It's a process of creating small, stable data structures from complex groups of data. So if you look into the process of normalization in detail, there is a what we call normalization step 1, step 2, and step 3. So this DBA normally will be carrying out these steps, normalization step 1, step 2, and step 3 in order to have finalized, optimized data so that the data can be used by the business in the most efficient manner. That's the whole idea of going through this step in designing the databases. An example of unnormalized relation for order, as you can see in the next slide, where we have an order and we have a long list of what we call fields or attributes. Fields or attributes, and this is not a good structure. Reason, too many fields, too many fields. So this is what we call an unnormalized relation. When you have an unnormalized relation and when you plan to access the data, it will take longer time for the system or for the database to search for the data. That is not good. That is not a good way of organizing the data. So what we will do is basically we will try to normalize the table, that particular order table, so that we have lesser field, lesser attribute, so that the data that you're looking for can be accessed in a faster manner. So what you can see in the next slide is where the table order has been broken down into, for example, order part, supplier part, and so on. So now you're having lesser key. So after you do the first normalization, second normalization, third normalization, what is happening is actually you're breaking or you are reorganizing the tables into more proper structure, so that if you are really looking for the order detail, just access these three fields. But if you are looking for the order part, there will be another file that you need to look at. So actually you're cutting down the access time, the time taken to access that particular data or information in that file. So now your database or your overall system will respond quicker, and shorter time will be taken to access the information that you're looking for. That is the whole idea of having a normalized table compared to unnormalized table. And this is only can be done by having a database environment. It's not possible in a traditional file system. Okay, so I hope I have cleared that in a very simple manner, but there is a very complicated steps or jobs involved in doing this. Moving on, some of the symbols may be not so useful for you, but just for your information, that the DBA or the system analyst will use when he has to design the database. The logical or the conceptual design, where we use like a square box, rectangular box to represent the entity, the diamond box to represent the relationship, and the oval shaped box to represent the attribute. And this is how the ERD diagram would looks like. One, it is designed and implemented in terms of ERD diagram. Yeah, so we have order, part and supplier, as you saw earlier, after the normalized process, and with the order number, part number and supplier number as a primary key, as a key, main key, and the rest of the field can be either foreign key or secondary key. It depends on the need. And also you can see the diagram itself has some symbols here which clearly tells that order belongs to order part. Order part includes order, for example, yeah, with some explanation, self-explanatory words are being used in the ERD diagram to make it clearer. But again, this diagram is not for any ordinary people. It is for the IT development team to understand this diagram so that they can start doing the system development or database development work. Yeah, just to share with you. You may not need this, or you may not be involved in doing this, but just for your information. Next, what we're going to do is we're going to cover the area still related to creating a database environment, what it means by distributing databases. All right. For those who are familiar with businesses, as you understand, we have what we call centralized business, and we also have what we call distributed databases. This type of businesses all being supported at the back end by these databases. So the popular databases to support the distributed businesses is what we call distributing databases. How the data are being distributed. For example, we have bank, and the bank has a HQ in KL, for example, and branches all over the country. So there must be a master file for all the customers of that particular bank, and this master file normally will be kept in the HQ of the bank, which is in KL. But the same file also will be converted into what we call a live file or working file, or will be known as a customer file, which can be accessed in real-time mode by the branches. Doesn't matter whether you are in the northern part of the country or in the southern part of the country. It should be accessible on real-time basis, and the information in that file must be updated. Yeah, updated, so that there is no question or doubts, for the customers, right? So two ways of creating these databases, or two ways of accessing these databases. In other words, one is to have a centralized database. The other way is to have a distributed database. What are the differences? What are the differences? Okay, let's look at the centralized database first. Before that, give me a minute. Let me check the meetings. Is there any questions, or anybody got any? Yes, let me see what is there. All right. The same question is being raised by Mr. Jiang. I would like to ask about our assignment and the final exam. Okay, we will discuss this after my class. Okay, I will bring that up again. Let me continue with my lectures now. All right, how are we going to access the data in two different ways, either by having a centralized database or distributed databases. First, let's look at the centralized database. Using or used by a single central processor or multiple processor in a client-server network. So in this environment, like I mentioned earlier, in a centralized database, the database will be in the HQ. Is actually implemented at the HQ, and the rest of the sites or branches the access on real-time basis to the centralized database. So the database is only at the central site, at the HQ, not at the site. All the terminals or all the devices at the site are connected directly to the central database and accessing all the information through the private or virtual private network. And the virtual private network or the private network must be having very good facilities, high speed network, so that all the branches, doesn't matter whether it is in the northern part of the world or southern part of the world, can access the centralized database as fast as possible, so that the customer or the user don't feel the delay. So the infrastructure, the security, the support, everything else must be up to date, must be very good. Yeah. uh, there are advantages and disadvantages in such a setup, which we can discuss later, because right now the entire data is in one location, yeah, at the HQ. And just imagine if anything happened to the central corporate data, all will not be able to access. Yeah. But of course, within the IT, we have many mechanisms, many methods to make sure the data is safe. Technically, the data will not be safe in one location. Technically, the data will be safe in 3 different locations at least, so that the data is guarded, is safely accessible by all the customers or users at all time. Yeah, that is technical. I'm not going to discuss about that. The users or the customers don't have to worry about that. But the higher level disadvantage is all the data is at one location. Yeah, that is a big question. Is it safe, for example? But this is how the databases has been set up and used for many years. Security is higher in the central environment, so that there is no much of risk. The databases is at the central, so the security at the central environment is very high, so risk is very low, yeah, instead of having the databases everywhere. So those are that is the advantage of this centralized database. So the branches, they have to have a direct link to the central location in order to access the database or information, versus the distributed databases, where over here the databases can be decentralized either by partitioning or replicating. And this is what we have today. Many businesses are into this mode or into this method for many reasons. Yeah, for many reasons. So that's why the distributed databases are becoming very popular nowadays at present and moving forward. What it means by partition database. Database is divided into segment or region. For example, a customer database can be divided into Eastern customers, Western customers, or depends on the business need. This is a very good point, because when you go to your bank, for example, you are in a central, you just need to access databases within your region. Yeah, you don't need to access databases from the northern or from the south, unless it is really necessary. The links are there, but most most of the time or frequently you don't access them. You only access the data or the customers within your region. Yeah. For that reason, it's like based on demand. Yeah. If you are in the central region, most of the time you deal only with the central region customers. Why you need to keep all the customers details from the north, from the south, east, west, and so on. So this was the argument, and then based on all these feedbacks and response, they have partitioned the databases in a way that it safe only required or most frequently accessed information. That is one good logical point. for creating or for partitioning this database into segments or region. To support this kind of businesses, they have come out with this, what we call distributed databases. And then they to cater other requests. For example, let's say you travel, all the way from northern to the region, and you want access to your information. To support this kind of customers, there will be some cases, or someone from the bank also need to access information from the northern region, for example. To support such cases, what is available is the DBMS system will duplicate the database and keep a copy at all the location. So with that, the data is still available, but the data is not being accessed on real-time basis. It doesn't come under the what we call frequently accessed data or information, only based on need. Regardless of which method is chosen, the DBA or the data administrators and business managers need to understand how the data in different databases will be coordinated and how business processes might be affected by the decentralization. Sometimes they don't want to duplicate the data too much. They will tell you, I'm very sure you have experienced this, or your record or your data is in northern, so you have to travel down to northern to close your account, for example, or to get more details. That is due to your data is not available in the central location. It's only available in the northern region, so you still need to travel down, because they don't want to keep the entire data in all the databases, because the size required or the amount of data is huge. Sometimes it runs into hundreds of millions of records, so they need to have huge databases in all locations. If that is the case, it will cost the company too much of investment or cost. So to save or to cut down the cost, they have some what we call policy or practices by the sites, by the branches, to save the cost involved in this case. So the business managers and the DBAs will be all notified or keep informed on such a arrangement. Okay, for example, what you can see in your next slide is this is how the distributed databases works. So you have partition database, remote database partition A and remote database partition B. For example, there are two sites. So you have the central database, and then there is a host, main server, and then the server is connected to the two remote sites, for example, and then the same databases is being duplicated over here and kept just in case it need to be accessed. Otherwise, it also can be a backup version of the central database. There are some advantages and disadvantages of these distributed databases as well. For example, in terms of advantages, it reduces the vulnerability of a single massive central database. As I mentioned earlier, you don't need to have a massive, huge database at every site. Disadvantages, it depends on the infrastructure, right? You still need to invest on the infrastructure. If your infrastructure is good, everything will work fine. But if your infrastructure is not good, then there will be some issue. Local database can sometimes not really updated due to some issues, but there is a solution to overcome this problem. It's not an issue anymore. Security problem also, we don't see a problem anymore, especially nowadays with a very advanced technology. All these are taken care. All these are taken care. End of the day, the bottom line is we want to make sure the data quality is high priority, for the customers or for the users, so that when come to decision making, there is no impact. It helps, as required in decision making. When it comes to audit, it supports the audit. All informations are available as required, following the policies and procedures, as well as backup, data cleansing, all done accordingly, according to the IT policy. So to make sure the data quality is not affected at all. This slide may be slightly quite complicated, or a lot of technical details are there for you. You can actually skip this OLAP process, which comes under multi-dimensional data analysis. This is actually for the DBA, DBA. So either you read through or you can skip this slide. So this is how the multi-dimensional data model looks like. It's actually 3D, we call it multi-dimensional. It's more than the 2D traditional databases. It has a projected new databases, actual databases with all the details, and divided or distributed into east, west, and central based on region. So it's very complicated. It's the job of the DBA to create such a database based on the business requirement. And also the trend in databases is quite outdated data here, but if you look at the latest data from the internet, it's all 3D, based on 3D, based on location, based on product, infrastructure, and also based on time. Is progressing into very advanced features, especially we talk about AI related databases, big data based databases, which are very advanced compared to all these databases. So they also have given you some database trend based on countries and based on companies in those countries and the trends. So spend some time to go through all these slides. It just gives you some information. Of course, you can find the latest information on the internet. Most of the big companies, big players, they have huge number of data, which definitely needs very high level or sophisticated databases to manage those data, to manage the number of clients. And whenever the company has what we call warehouse or data mining, definitely it need to be supported by sophisticated database such as Oracle, Informix, or DB2, so that hundreds of records or thousands of records can easily be generated based on user demand or customer demand. So normally these data warehouses supports reporting and query tools, stores current and historical data. There will be a very complicated what we call data management analysis work, data analytic work. Data are standardized, consolidated, and so on. I'm very sure some of you are having a very good business background. You understand what is data warehouse, and there is a huge amount of data involved in managing the data warehouse and data mining. and there are many aspects of databases are involved, especially when it comes to different types of databases. For example, we have customer related CRM system, logistic related databases, supplier related databases, and so on. So all these databases are for different department or for different needs of the business, but as far as the business is concerned, all these databases need to be linked, need to be connected, so that to a customer, to the user, they don't see the detail, the technical aspect of it, but they need to access, they need to have the data and information that they are looking for. Yeah, that is the whole idea. Okay, in the next slide, what you can see is a component of data warehouse. In the warehouse, we do have what we call internal data sources and external data sources. Internal data sources are such as we have company operational data, historical data, and so on. And in the external, we do have some data from external parties, such as we may have external suppliers, external customers, external producers, and so on. So you may need some data from external parties for your business, for you to continue your business. So the databases or DBMS in the data warehouse will extract and transform and link, analyze all this data, required data, so that it can optimize, normalize it into the format of where queries and reports and data analytical work and data mining work can be done to support your business. Yeah, so that's how an example of database that is available in the warehouse operates, operates or being used by the users in the warehouse to support the business. And there will be many parties involved in this environment, such as the DBA, users, SA, system analysts, and so on. Okay, it's going to be 9 o'clock, so there are a few more slides. I am not planning to run through this now because it is a bit too much of information.